Hello and welcome to IGCSE Mathematics 0580 extended course. In this video, we will be covering syllabus topic E1, which is about number, and the module we'll be discussing is E1.1 part 2. And this is the book we will be using, as you probably already know. This is the most authentic and well-written book for IGCSE Mathematics, and I will highly recommend you to use this book. This is written by David Rayner, and this is for extended course. Right, so let's start exercise 5 of chapter number 1. In the question number 1, it says which of the following are prime number. So guys, before actually we start solving this, there is a little technique to determine either a given number is a prime or not. So let's start with this example. Let's suppose you are given a number 37 and you're asked whether this number 37 is a prime or not. If you don't know this technique, so what you will do, you'll just try to divide this number 37 with different numbers starting with the 2, 3, 4 and so on. But this is not a smart way of doing it while you are sitting in the examination hall. So you must know some sort of technique which can reduce your time and efficient as well. So the best way is that just take the under root, not by the calculator. You can just do it with your mind as well. So of course we just need the whole value. It is 6 point something because 6 6 are 36 and 7 7s are 49, so it means that it is 6 point something. If you want to know the exact value, it is 6.08. we just need this whole value 6 at the moment. So the technique is that you will use only the prime number starting from 3 to this number 6. That's it. So the prime number is 3 itself, is it? 4 is not prime number, 5 is a prime number, and that's it. So now in order to find 37 a prime or not, you just need to divide 37 with these two numbers only. That's it. That will decide the nature of this number. So if you try to divide 37 with the 3, it won't give you zero remainder. It means that you cannot divide it completely. 37 divided by 5, once again you cannot divide completely. It means 37 is a prime number. Let's take another example quickly. Let's suppose this time you have a number 51. So once again, if you take the under root of 51, it is 7 point something. It is in fact 7.14 something. So we just need the 7 value. Once again, the same technique. You just use the prime number starting from 3 to until this number, which is 7. So just list down the prime numbers. 3 is a prime number, 4 is not, 5 is a prime number, and 7 is a prime number. That's it. Now you just need to divide this 51 number with these 3 number. So if you try to divide 51 with the 3, yes, it does go, because 3 into 27 makes 51. It means that 51 is not a prime number. In question number 2, it says write down the first 5 multiples of the following number. So as we discussed in our previous video, the multiple mean literally the table of that number. So it is, again, it's a very easy question. So you just need to write the table of these numbers up till 5. Question number 3 and 4 are very similar, so I'm just going to solve this question number 4. It says write down the first 6 multiples of 3 and 5, and then you need to find out the LCM as well. So first of all, let's write the multiples of 3. So as we know, the multiple of 3 is literally the table of 3 until 6. So 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, and 3 5s are 15, and 3 6 are 18. And the multiple of 5, once again, it's a table of 5 till 6. So 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, and 5 5s are 25, and 5 6 are 30. And you're looking for the LCM now. So the least common multiple means the smallest number which is common between these two. So let's start with the 3, 6, 9, not there, and see that 15 is here. So 15 is our answer. 15 is the LCM. By using the other method, as we discussed in the previous video, if you need to find out the LCM of 3 and 5, so you're looking for something which can divide 3 and 5. So there's no any number. It means simply you need to multiply 3 and 5 together. That makes 15. So 15 is the LCM. So in question number 5 it says write down all the factors of the following. So I'm just going to do that question number 24. So I just already written down the factors of 24, if you remember, starting with the 1 and the 2, 2, 12 to 24, so 2 is a factor, 3, 8 to 24, so 3 is a factor, 4, 6 to 24, so 4 is a factor, 6, 4 is 24, 6 is a factor, 8, 3 is 24, 8 is a factor, 12, 2 is 24, so 12 is a factor, and 24 itself is a factor. So these are all the factors of number 24. Question number 6, part A, it says, is 263 a prime number? So we will use the same technique. We will take the under root of 263, which is equals to 16.2. We just need this whole value number. So once again, as you know, we will use all the prime numbers starting from 3 up till 16, whatever prime numbers we have from 3 to 16. So let's down all the prime numbers. So the first prime number 3 itself, then 4 is not, 5, yes, 5 is the prime number, 6 is not, 7, yes, 7 is the prime number, 8 is not, 9 is not, 10 is not, 11 is a prime number, and then 12 is not, and then 13 is a prime number, then 14, 15, 16 are not prime number. So it means that to check 263 is a prime or not, you just need to divide with these 5 numbers, 3, 5, 7, 11 and 13. If you divide this number, you will find out that none of these numbers can divide 263 fully or with the remainder 0. It means that 263 is a prime number, right? So in the next part it says how many numbers do we need to divide 263? So of course you need to divide with these 5 numbers in order to check 263 is a prime or not. In part B and C of this question number 6, it's the same strategy, so I hope you will be able to do them as well. In question number 7, he's asking you to make some prime numbers and he has given some numbers, so it is a very easy question. You just make the combination starting with the 1 and use all those numbers and just see if you can make as many prime numbers with these available digits. I'm sure you will be able to do that. It's not that difficult at all. In question number 8, it says write the following number as the product of prime factors. So I'm going to solve this part C, in which the number is 90. So we use this once again the same techniques. 90 is the given number and you will be finding all the prime factors. So it means that you will be allowed to divide all those numbers which are prime on this side. So let's suppose start with the 2, because 2 is a prime number and 90 is an even number, so you can divide 90 with the 2. So 2 45s are 90, and here 45 you can divide with the 3. 3 is a prime number, so 3 15s are 45. Once again it can go with 3. 3 is a prime number, 3 5s are 15, and that's it. It means that 90 has the prime factors 2 into 3 into 3 into 5, or more precisely you can write like 2 into 3 raised to power 2. As you can see, there are 2 3's, so you can make them as a power of 2 into 5. If you don't understand this technique, we'll be dealing in great detail in the dices chapter later on, right? So these are the prime factors of number 90. So in question number 9 it says find the highest common factor of. So we're just going to solve that part B, in which it says 90 and 144. So we will use the same technique as we have discussed to find the ACF. We have two numbers now, 90 and 144. So as we discussed, we will use a number which can divide 90 and 144 simultaneously. So let's say we start with the 2. So clearly you can say it's an even number, so 2 can divide 90 and 144. So 2 4s are 8, 1 carry, 2 5s are 10, 2 7s are 14, and 2 2s are 4. Now we have 45 and 72, they can divide with the 3. 3 15s are 45, 3 2s are 6, 1 carry makes 12, and 3 4s are 12. Now 15 and 24, once again we can use the table 3 to divide with both numbers 15 and 24. 3 5s are 15 and 3 8s are 24. That's it. We have to stop here because 5 and 8 cannot be divided by the same number. like there's no common factor between 5 and 8, so you have to stop here now. Now for SCF you simply multiply these three numbers together, means 2 into 3 into 3, that makes 3 to the 6, 3 3 are 18. So 18 is the SCF of 90 and 144. In question number 10 it says find the lowest common multiple of we're just going to solve that B part, 60 and 90. So we will use the same technique, 60 and 90. So preferably we'll use the prime factor, so we can clearly see it can divide, 5 is a prime number and 16, 19 and 90 can be divided by number 5. So 5 ones are 5, 1 carry makes 10, 5 2s are 10, 5 ones are 5, 4 carry makes 40, so 5 8s are 40. Now 12 and 18 can go with the 3, which is a prime number. 3 4s are 12 and 3 6 are 18, and again it can go with the 2, which is a prime number, so 2 2s are 4 and 2 3s are 6. Now 2 and 3 cannot be divided by the same number, so there is no point of dividing it further. So as we know that for LCM you just need to multiply all of these numbers from here till here. So it is 5 into 3 into 2 into 2 into 3, which makes 5 to 3 are 15, 15 to the 30, 30 to the 60, 63 are 180. So 180 is the LCM of 60 and 90. So in the next video we'll talk about rational and irrational numbers. See you there.